Hi everyone, this is example 5 from chapter 15 in your student packet. A startup company is about to market a new printer. It decides to gamble by running commercials during the Super Bowl. The company hopes that name recognition will be worth the high cost of the ads. The goal of the company is that more than 40% of the public recognize its brand name and associate it with computer equipment. The day after the game, a pollster contacts 420 randomly chosen adults and finds that 181 of them know that this company manufactures printers. Would you recommend that the company continue to advertise during Super Bowls? Use a significance level of 0.05. So we're going to run a hypothesis test, specifically a one proportion z-test, since we are given a proportion here. So this is the population proportion that we are then comparing our sample proportion to. So I don't have a lot of room to write out all of the conditions that need to be met, so I'm just going to talk through them really quickly. We want to make sure that the sample is random, which we have that there. There's randomly chosen adults. We want to make sure that the 10% condition is met, and there are millions of adults in this country, so 420 is definitely less than 10% of that population. Which means that our individuals within our sample are most likely independent. And then finally, the success-failure condition for proportions. In this case, we have a success of 181 out of the 420, so that's greater than 10, which means that the failures, which would be 420 minus that 181, is also greater than 10. So all of those conditions have been met, and we are going to run a one proportion z-test. The hypotheses, this company wants to know if more than 40% of people recognize their brand. So that's going to be the alternative hypothesis, that it's more than 40%. And with our text, the null hypothesis is always equal to. So then we're going to go and use our calculator. We're going to go to Calc Tests, and we're going to choose number 5, which is the one prop z test. Our p sub 0 is the null hypothesis proportion, which is 0.4. The x in this case is 181, and the sample size is 420. And for our alternative hypothesis, the proportion is greater than the null hypothesis. And when you put this in your calculator, you will get a z equal to 1.295 and a p-value of 0.0, oops, I said 0, I wrote 9, 0.977. So remember that the p-value is the probability that we would observe this sample given that the null hypothesis is true. So given that the population proportion is 40%, there's about a 9.7% chance that we're going to observe this sample. That's a pretty high p-value, and notice that the z-score is also not that unusual. So our conclusion should be that we're going to fail to reject this null hypothesis. So, conclusion. Since the p-value is greater than alpha equal to 0.05, we fail to reject the null hypothesis. And conclude that there is not enough evidence to suggest that more than 40% of adults recognize this brand. So I just want to talk a little bit about rejecting the null, failing to reject the null. So what we're doing when we're doing a hypothesis test is we're seeing that if our sample proves our null hypothesis as false. So in this case, we're saying that it doesn't, since there's such a high probability that we would observe this sample statistic. So since it does not prove that the null hypothesis is false, then we're failing to reject the null hypothesis. We are not accepting the null hypothesis. We're not proving that the null is true. We're not proving that the alternative is true. The only thing that we're trying to do is prove that the null is false, and we could not do that. So that's why we fail to reject it. So the question is, should this company keep advertising during Super Bowls? We've established by this test that the proportion of adults is not greater than 40%. So what is it? What proportion of adults do recognize this brand name? And that's where the confidence interval comes in. So we're going to find a 1 proportion Z interval. So you'll go to stat tests, and remember you have to scroll down a little ways in order to find that. And when you get there, I want you to notice that the calculator has already, has already entered in all your information that was there during the test, because your calculator is expecting that you're probably going to run a confidence interval after you've performed a test. So it already has this information. We're doing a one-tailed test with a significance level of 0.05. So we're going to then do a C level, a confidence interval of 0.95. So when we do a C level of 0.95, we get a confidence interval of 0.38359 to 0.47831. So what this confidence interval is saying is that the true proportion of people that recognize this brand is somewhere between about 38% and 47.8%. So the true proportion could be above 40%, but it also could be below 40%. Remember, we're not sure where that true population proportion is. So that's why this confidence interval supports our test, because the confidence interval does not somehow prove that null hypothesis is wrong. So it supports our test because note the null hypothesis is within the interval. And so that's why it supports failing to reject that null hypothesis, because the null hypothesis is contained within this interval.